The second way to divide polynomials is using synthetic division. Synthetic division is a shortcut when you're dividing polynomials instead of using the long division. It is a special case, and it must be divided by a binomial when the leading coefficient is 1. However, it can be divided, when the leading coefficient and the divisor is not 1, but it's a little bit more difficult, a little bit more steps involved. Synthetic division is used, that we'll use later, for not only finding out factors, but finding zeros or roots of polynomials. We'll learn more about this later in the unit. Okay, so our first example was synthetic division. It's a little different. It's actually more fun, in my opinion, to do this versus long division, but it's another way of solving. Now, x minus 3 here still represents the divisor. X minus 3 also represents a factor to this polynomial. So we're trying to find the other factor to give us the polynomial given. Now, since we are working with synthetic division, it's a little different. In order to do synthetic division, we need to take our divisor, x minus 3, and set it equal to 0 to give us one of our zeros, our roots, which is 3. Okay, and we'll use 3 in our synthetic division. So we have this long bar, like an upside down radical, we'll use. And from here, we're going to put our leading coefficients of every term inside this box. So we have 2, so 2 will go here. Negative 3 will go here. Negative 10. And then 7. So make sure you do put the signs that go with, especially when it's negative. And so from here, what we'll do is we're going to bring down our 2 here to be 2. We're going to then multiply this 3 here times 2, okay, and so that's going to give us 6. And then from here, we're going to add negative 3 and 6, and we're going to get 3. And then we're going to repeat that process. So 3 times 3 is 9. Okay, and so then we're going to add negative 10 and 9. So we get negative 1. Multiply again 3, the outside number, times negative 1. I'm going to get negative 3. And then again, add 7 and negative 3, we get 4. And also the last number that you get will be your remainder. So we have a remainder of 4 in this case. And so basically, when we're done, we need to take what we have here and write a polynomial. So we're going to have 2x squared. So we descend one down, one term, 1 degree, 2x squared. Plus 3x minus 1 with a remainder of 4, so 4 over our divisor, x minus 3. And then we're done. So this next example is a little different, and the reason why is if we look at our given polynomial here, our dividend piece, x to the 4th minus 81. It is missing terms, and if you remember what we talked about earlier about missing terms, we must use a placeholder 0 to represent the missing terms. So this polynomial should say x to the 4th plus 0 x to the 3rd, because it's missing x to the 3rd, plus 0 x squared, it's missing that, plus 0x. Then the minus 81. So anytime we're missing terms, you must use 0 as a placeholder. So now we're going to do the same thing we did in the last one, use our synthetic division. Here's our divisor. So my 0, my root, I'll be using in my synthetic division is 3. So 3 will go on the outside of my big long radical. So my coefficients will go on the inside. So my coefficient for the first one we have here is 1. This second coefficient is 0. Third, fourth are all zeros. And then the last one negative 81. Okay, so we always bring down this first term 1. Okay, so we'll always bring that down, and then from there we'll multiply. So 3 times 1 gives me 3. Okay, then I'm going to add 0 and 3 to be 3. Multiply again, 3 times 3, 9. 0 and 9 added together, 9. 3 times 9 is 27. Then we're going to add 0 and 27 to be 27. And then lastly, multiply 3 times 27 is positive 81. And so we're going to add those. In this case, we're going to have a remainder of 0. So we'll take what we have here left over, that will make our polynomial. Again, since we started with x to the 4th, this next term will be x to the 3rd. So we have x to the 3rd plus 3x squared plus 9x plus 27. And we don't have to use anything for a remainder because there's nothing there, so we're done. Okay, so our last example was synthetic division. You see the format's written differently, but it still means that we're dividing. The last one here, I say for the last, best for last, I guess you could say, our divisor. Our divisor, 2x plus 3, if you notice the 2x, our leading coefficient, is not 1. So this is the case when a is not 1. When you're using synthetic division, you can't just, solve it like the normal way we have been doing when your leading coefficient's not 1. Okay, so there's some other things you got to take in consideration. You still, however, take your divisor, 2x plus 3, set it equal to 0, and know that you will have negative 3/2 as your divisor. So negative 3/2 will go over here. Set up your bar. Another thing that you're going to do differently, and I would do it now, is divide all your leading coefficients in the numerator by 2. Okay, and so then what we're going to have is new leading coefficients that we'll be looking at, which will be 1 x to the 3rd plus 11/2 x squared, leave it as a fraction, minus 1x minus 25 over 2. So we're going to use those coefficients, so 1, 11/2, negative 1, negative 25 over 2. Again, leave them as fractions. Okay, so we're going to do the same thing, which is bringing down our 1. So we get 1. We're going to multiply 1 times negative 3/2. We're going to get negative 3/2. So see how our fractions end up having the same denominator, so it makes it easy to add. We get 8/2, which does not change to 4. So now I'll look at 4 times negative 3/2. That's going to be negative 6. Add that to be negative 7. And then multiply negative 3/2 times negative 7, and that will be positive 21/2. Add, that will be negative 4/2, which will be negative 2. Okay, so now my polynomial is going to say 1x squared plus 4x minus 7 with our remainder of negative 2. Now I'm going to write this a little differently. X plus 3/2. And the reason why it was x plus 3/2 is if you go back up to here, if I were to rewrite this as a factor, it would say x plus 3/2, because this is before I would have solved it, for 0. Solve for it, set it equal to 0. But right here with our remainder, we're actually not done because we don't want to leave it as 3/2. And some of you are probably thinking, well, why can't we just write it as 2x plus 3 like it said in the very beginning? Yes, we will. It will change to be 2x plus 3, but the way it changes to be 2x plus 3 is we have to multiply the numerator by 2 and the denominator by 2. So really, the new remainder is going to be -4 all over 2x plus 3. Okay, so you have to then, when you have it's only the case when you have a remainder. Your remainder, you're going to have to go back and multiply by what you divided by, which was this case a 2. We divided by a 2, so I have to multiply numerator and the denominator by 2 to change my remainder. So the final answer is going to say, I'm going to write it in this place right here so we don't get confused with everything, but it's going to say x squared plus 4x minus 7, we can just put minus here, 4 over 2x plus 3. And that's supposed to be a 3 there. And we're done. I also wanted to say one more thing with this problem. Going back to, this section right here, where this is where some of you might, kind of get confused. We had to multiply by 2, numerator and the denominator, because of what we divided up here. Use my little pointer up here, okay? So whatever the case may be, we'll multiply at the very end. Since we divided, we're going to, in return at the very end, multiply by 2. Okay, so, but I just wanted to clarify one more thing down here, so 2, the reason why, some of you are probably thinking, well, x plus 3 halves, why can't I just write 2x plus 3? Well, the reason why we multiply by 2 is if I multiply by 2, 2 times x is 2x, 2 times 3 halves is 3, because 2 times 3 is 6, divide by 2 is 3. So that's why it all changed, that's why it works that way. Just wanted to make sure we clarified that. Okay, I said that was the last one, which it was, but I wanted to make sure we have all grounds covered with this problem, because this one, like I said, it is different because of our divisor being, our leading coefficient not being 1. Now, the last one I said, divide everything by 2 first. Well, what if we didn't do that? What makes it different? Well, let's just look at it real quick. So our divisor, 2x plus 3 equal to 0, we're going to still use -3 halves. Okay, so let's just do it without having, that first step being dividing everything by 2. Okay, so we're going to use the coefficients 2, 11, -2, -25. Okay, so treat it the same. Bring down the 2. Multiply 2 times -3 halves, -3. Add 8. 8 times -3 halves, -12. Add -14. Multiply, that will be positive 21. Okay, and then we add and we get -4. So, does this -4 look familiar? I hope so, because that is our remainder. But if you look here, we have 2, 8, and -14. But our last answer, we had, 1, 4, and -7. Well, we're still going to get that because since we did not divide by 2 first, you're still going to have to divide by 2 at some point. And so you can do it at the very end if you would like, but this time you don't have to worry about dividing it by your remainder because it's done already. So if I divide everything by 2 now, it will be x squared plus 4x minus 7 minus 4 over the 2x plus 3. So now I don't have to worry about doing anything special at the very end. But again, you're going to have to remember that you're going to have to divide by 2 somewhere at some point. Or when I say divide by 2, you're going to have to divide by whatever your leading coefficient is. If it's 3, 4, 5, 10, whatever it may be, you're going to have to make sure you do that part at some point in the problem. So you just pick which way you like.